Okay, welcome to a new video. This video we're gonna study about statistical inference. Okay, before we begin this topic, we need to be familiarized with the formula. Formula will be given for this kind of question. We will see the formula, then as usual we'll see the example questions. For the formula, I'll be explaining what we need to do and how to use the formula as well before we begin. So we'll use this color marker. Okay. First and foremost, we need to know the confidence level interval. So for each, we have the ZA over 2. So if it's 90% confidence level, so confidence interval, we need to have 1.65 as our ZA per 2. If it's 95%, it's 1.96. If it's 99%, it's 2.58. So that is the first stuff that we need to be familiarized with. This thing could also be found in the table. So I don't have the table now, or I can show the table if needed. So this is the table. For example, if you want to find 0.25, so 0.25 is 1.96. okay, so 0.025, sorry, 0.025, it's 1.96. so 0.025 is for 95%. So we can find this using this formula. Okay, so confidence, and then confidence is the percentage. So if 90% confidence, we just put 90% confidence, then we get the A, then we need to A per 2, then we follow the table to identify it. Okay, then we have the confidence interval in order to find it. Okay, so this is the formula for it. Then actually this is plus minus, so we would be having a minus over the x, and then we have the plus value. Okay, then we have the sample space. Sample space is also same, E for marginal error. This would be given in the question, so no need to be worried. And this is the other way around. This is the sample size. This would be given. So if they're asking for sample size, they will be given the E. If they're asking for E, they will be given as the N. Okay, and the population proportion is just the same, the P. So P is the success level. If the question is talking about failure, or P is failure. If the question is talking about success, or P is success. P is the probability that we are trying to achieve in the statistic, and Q is 1 minus P as known. So this is the formula. So this is simply Q. So P times by Q and over N. And here also we will be having minus over proportion and plus value of the proportion. So the sample size, as stated, E would be given. If E it's not given, then the question would be asking about N. Sorry, wouldn't be asking about N. If the question doesn't give E, the question would be asking about E with N is given. Okay, then we have two types of error. Type 1 error, the alpha error, we reject the H naught where H naught is there. Meaning if H naught is woman prettier, so if we are rejecting it, meaning H naught is true, women are prettier. If in a sample space of N where everyone is a woman, all are women, and women are prettier, technically it's true. But if you're rejecting it, it's type 1 error. We call it the alpha error. So type B error is we don't reject, but we know that H naught is false, meaning in a group of N there are men, then we are telling everyone in the room is prettier, but men are not prettier. But if it doesn't reject, it's type 2 error, it's beta error. Okay, then we have the test statistic, we have the Z score, we have the mean. These are different. Okay, in the question we will know that. And another thing, S is standard deviation. So we have two simplifiers. This is also standard deviation, S is also standard deviation. Not be confused with that, because some formula gives S, some formula gives in the standard deviation symbol. Then over N. So this is another formula. Okay, so we already covered the formula. These are the main formula that we'll be using, and the formula will be given. Okay, now we'll be seeing the sample questions. So this is the first sample question. Okay, so in the first sample question, we know here that, okay, nice. A publishing company publish new textbook. Before the company decide price, the research department at the sample of 36. Okay, sample means n, and then we have the population price, and then we have the standard deviation here. Construct a 90% confidence. So we have n, we have our x, or known as the mean, and then we have our standard deviation. Okay, now, okay, they said 90% confidence level, so in order to find it, we are using, or if you know what is 90% confidence level for, like 1.65 here, then just write 1.65. Then we are using this formula. Okay, using this formula, using the data we have, and I said it's plus minus, so this is the minus value, then we have the plus, so is between. So the one that we are finding should be falling around this given lower limit and also upper limit. Okay, so this is one example I got. The second example would be, okay, this is the second example. This is for the error. Okay, now for the error, if you see, I mean the of a river, so he chose 99% confidence, you know that 2.58, the ZA2. Okay, then we have the sampling error E is 2 feet, so they want to find the sample space n. So we know that in order to find the n, we need E. So E is given, and then the standard deviation is 4.33. So this is the formula, and the formula is being used. As said, we need to round up, so the answer is being round up. Round up means we need to round up. Okay, if it's 31.1, just round up to 32. Okay, if it's 31.6, still round up to 32. Okay, now next one would be 133. So this is also the same, but this is the error that we need to find. Okay, so in this case, n is given, and then standard deviation is given, and 99%, meaning we need to be using z for 2.58. so 2.58, and yeah, where's the e, with times, sorry. So this is the answer. Okay, alright, next we would be seeing one. Okay, this is for the portion. Now for this question, if we see, we have our sample here, then we have 600. In order to find the p, we need to take our mean per n. So this is the formula. Now by that case, then we know that 95% is 1.96. okay, now using the plus minus, meaning we need to do the minus here, then we need to do the plus here. As said, it's just the same. You will get your lower limit, and you will get your upper limit. So lower limit, put it here, then upper limit, put it here. Okay, so you just plug in the values and you will get the answer. It's simple. Okay, then we have 142. This is for the error, sorry, this is for the number, sample space. So this is the formula here, so this is how you use it. As said, the error is given, and then we have 40%, so meaning the p, and 95% confidence level, which is 1.96. then we have 161. Okay, this is for the H0 and R. So okay, we are here. This is to accept, reject in statistical medium. Okay, so average monthly earning for women 2400. So men is earning more not. So we are given X, we are given S, and we are given A with the N. Okay, so we calculate the Z using the statistic formula that is given. Now we'll get 18.97. For the 0.01, it shows that we need to find it. Okay, so we'll take 99% and we'll get 2.363. okay, so this is the majority, 2.33. so 18.97 is more than 2.33, so it fails. So our mean is average monthly earning is 24. So are men earning the same? We are telling that men are not earning the same, so we need to have two hypotheses. One is where the case is same, or the case is supporting the statistic or the argument that we are bringing. Another one is where the argument is failing. In this case, the argument that won was H1, so technically we are rejecting H0, which we are supporting H1. Men are earning more than 2400. So this is the stuff that you need to remember. In order to reject H0, you need to say that H1 is claimed to support, so H0 is rejected. These are the keywords that need to be have in the argument or in the statement that you need to argue. So if you are bringing an argument and you need to prove that the argument is wrong or you're supporting the argument, you need to have this such words to support your statement, as in order to win the argument or in order to reject the hypothesis. Okay, next is, okay, this is another example for it. Okay, so sugar packed 5 pound, inspector may say that it's not 5, then they take sample space 50 and standard deviation as 0.7 and the A is 0.05, which means it's 0.025, and 95% confidence means 1.96 they have given it. So plugging it everything in the formula, we know that we are getting negative 4.04. so negative 4.04 is lower than negative 1.96 because we have plus minus range. Okay, so they reject the null hypothesis. You have another way to solve this. You can use the confidence interval. So confidence interval is saying it should be 4.4 till 4.8. so 5 pound is more than 4.4 and more than 4.8, meaning you can reject the hypothesis. You can either use either formula. Okay, then this is another question. Okay, 4% defective chips, whenever it's producing more, so our P is near 4. Sample of 200, n is 200, line contain 14, meaning that 200 minus 14 equal 186 is okay and 14 is not okay. Test at 5% significance level. 5% significance level means 0.05 alpha. So ZA per 2 is 0.025. Okay, significance level and confidence level is different. Okay, significance level is A, so 5% means 0.05. confidence level means it's the level of percentage. Okay, so it's two stuff that's different. In this case we have the P0, it's just the same. Okay, in standard deviation this is S and this is X minus mean. Alright, so in this case the X is not given, the mean is not given, so we will be using this such formula because this is pass and this is not pass, where P0 meaning 1 minus P or equivalent to Q. Right, sorry, I was wrong. P was the total and P0 was the case. Where this is the defective or the original defective, P0 is the defective that we need to find whenever the P naught is the defective percentage, or the percentage that we have set for a machine for a group of argument, where the P is the real P. Okay, this proportion is the real proportion, and P naught is the estimated proportion. Okay, sorry for the confusion. Now, our hypothesis saying that the P should be less than 4%, the real estimated proportion of failure, but our written argument is H1, meaning that the proportion of defective is more than 0.04. So did we win? Okay, the ZA for us was 0.05, meaning ZA2 is equal to 0.025, which is 1.65. Was I? Oh no, in this case we don't need to divide by 2. So the ZA is 0.05, meaning it's 1.65. Remember, in confidence level, the percentage that we get, we need to ZA per 2. In this case, they have given the A freshly, we no need to divide per 2. I'm very sorry for 2 mistakes in this video. Since this is our alpha, but the Z that we are getting is more than alpha, so fails in the reaction. We could say that it's not 0.4, it's more than 0.4, as in the real world we are getting 7% failure, not 4% failure. As thus, this is the way that we need to do the statistical inference, where we support the argument, we are doing the confidence interval. This is, for example, if we are taking a group of person or sample population and we need to do an estimation of a larger scale. Okay, so this is the end of the video, and thank you.